Okay, in this video we'll quickly review the formula to determine arc length of a curve, and then we'll use that to determine surface area of a revolution. So in general, the formula for arc length is the integral between two boundary points of the square root of 1 plus a function's derivative squared with respect to the function in which it was created. So in this particular case, we're given an interval here from x values of 1 to 4. If I wanted to find the arc length s, that would be equal to the antiderivative, or the integral from 1 to 4 of the square root of 1 plus the derivative with respect to x of x cubed over 3 plus 1 over 4x. Take that quantity and square it, and again compute that integral with respect to x. You'll notice that I'm not worrying about computing the derivative by hand here. Since the calculator is permitted, we'll let it do all of that heavy lifting for us. And according to the calculator, that would be 339 divided by 16, or 21.1875. So similarly, we can compute the arc length in the next example. And again, we will use technology to evaluate this integral. So we're on an interval from 4 to 5, and we want the square root of 1 plus some quantity squared, and that quantity is going to be the derivative with respect to x of the function for natural log of x, and we'll compute that antiderivative with respect to x. Now you'll notice here that the solution, the exact solution that the calculator produces, is fairly large. In this case, if you don't want to write down that exact solution, I'm okay with it, and we'll just report the decimal equivalent, 1.3411. Okay, so now to take this concept of an arc length and determine a surface area associated with it, we just need to revolve this arc length around an axis. So in general, the surface area for a given arc length ends up being the result of this formula. Between two boundaries of 2 pi times some radius. Now the radius is going to be the function itself, 2 pi times the function, times effectively the arc length, 1 plus the function's derivative squared with respect to x. So that's our general formula for surface area. Let's see if we can apply it here. Looks to me like we have a boundary of integration between 0 and the square root of 10. We'll take 2 pi times our function this time, so our function is x cubed over 10, and we'll multiply by the square root of 1 plus some quantity squared, where the quantity is the derivative with respect to x of x cubed over 10, and we'll compute that integral with respect to x. And here's the result from the calculator on that one. Again, the expression is getting kind of large, so if you don't write that by hand, I'm okay with it this time, and we'll just go with the approximate answer, 35.6312. Now, similarly, we can compute this next one. Now again, if I forgot to mention, I've got 11 and 12 highlighted together because on the test day you'll be able to choose either one of those to complete. You won't have to do both. Now this one's going to be a little bit easier to work with because the function is a bit simpler, but the boundaries of integration aren't quite as clear because we're giving you coordinates instead of specific boundaries themselves. Now in this case, the surface area, again, is the boundary between two x values. We're revolving around the y-axis, so we have to find this derivative with respect to x. The x values of the coordinates are 4 and 9, so we're going to integrate between 4 and 9 of 2 pi times 2x minus 3, times the square root of 1 plus some quantity squared, where that quantity is the derivative with respect to x of 2x minus 3. Now the math inside here really isn't too bad. The derivative of a linear function is easy to compute, and pretty quickly you'll find how computing all of this by hand is probably manageable. So if you do decide to do this by hand, I'd be curious to see your work, and I may consider offering some bonus points for that. And I do recognize that in the interest of time, most of us won't go that pathway, and we'll just enter it into the calculator like we have here. 100 pi times the square root of 5 is a good answer. So 100 pi times the square root of 5, which is approximately equal to 702.4815. Okay, so again, I'm looking for the setup and the solution for each problem set. Okay, I think that's a good stopping point for this video. We've covered the surface area and arc lengths questions for the section of the test. And if you have further questions on that, please let me know. Thanks for watching.